Okay, in this video we're going to continue talking about inverse functions, and we're going to talk about finding the inverses of power functions and also using something called the horizontal line test on these functions to tell whether the inverse would also be a function. So let's get started with kind of a straightforward example, hopefully. Let's look at the function f of x equals x squared. Now, if you can use your graph paper to do this lesson, that'd be ideal, because what we're going to do is we're going to take a look at some graphs, and we're going to actually graph f of x equals x squared, and then we'll take a look at its inverse. Now, if we were to graph this, we can make a table, and some values we might plug in would be 0 for x, and if we squared 0, we'd get out 0. So if we had a plot a point, that would be the origin, right? If we plugged in 1 and squared it, we would get 1. So I would plot this point, and if I plugged in 2 and we squared it, we would get 4. So if we plugged in 2, we'd get out 4. And of course, we can plug in the opposites there, right? We can plug in -1, and if we square -1, of course, you get +1. So we can plot a coordinate there. And if we were to plot -2 and squared it, we get +4. So we get a nice parabola, U-shaped graph. So if I had to just draw a sketch, hitting those points, not the greatest line there. Let me try that again. Come down, hit the origin, and then come up through. There we go. So we get the following graph. Now, if I wanted to do the inverse relation, let's maybe use red. Hopefully this shows up well. If I wanted to do f inverse of x, remember what we did last time is we just switched the x and the y values, right? So if I did that, the old y values, or the original range, becomes the domain of the inverse. So I would have 0, 1, 4, 1, 4, and then the corresponding outputs for those inputs would be the original domain. So 0, 1, 2, -1, -2. Now if we plotted the inverse on the same graph, something interesting happens, and you'll notice in a second. If you plot 0, 0, still have that same coordinate, 1, 1, still right there. And then if we plotted 4, 2, that would be right here. If I can get it to work, there we go. And if we plotted, it's also saying if we plot -1, we would get -1, so that would be that coordinate. And then if we plot 4, we would get -2. So our graph here would look something like this. Now, the inverse, if you take notice, this is not a function, because if we were to use that vertical line test, I hit that line more than once. So the inverse, this is not a function, because it fails the vertical line test. And you can also look at the table of values. I have the input 1, for instance, giving me an output of 1, right? And it's simultaneously, I have the same input 1, and it's giving me a different output, -1, and that violates the definition of a function. We can't have the same input with two different outputs. And another way of looking at it graphically is